Technicians install, maintain, and repair heating, ventilation, air conditioning, and refrigeration systems to ensure indoor environments stay comfortable and energy efficient in homes, businesses, and industrial settings. In today's video, we explore 31 HVAC interview questions and answers. Each answer can be customized to highlight your unique qualifications and experiences. Before your interview, be sure to research the company and review the job description so you can include key skills relevant to the job role in your answers. Let's explore some general HVAC interview questions. Question number 1. Can you tell me about your experience as an HVAC technician? This question helps employers understand how well prepared you are for the role and whether your background fits the type of work they need. For experienced techs, it reveals your hands-on skills, the systems you've worked with, and how you handle real job conditions. For those without experience, they want to see your level of training, attitude, and how ready you are to jump in and learn. Either way, they're listening for technical knowledge, problem-solving skills, and professionalism. If you have previous experience working in the HVAC industry, you can use the following answer in your interview. I've been working as an HVAC technician for a little over 5 years now, mainly in residential settings but also some light commercial work. I've installed and repaired systems ranging from gas furnaces and central AC units to ductless mini splits. I'm comfortable with diagnostics, electrical troubleshooting, and routine maintenance. Over time, I've gotten pretty quick at spotting common issues like capacitor failures or low refrigerant levels, but I also take the time to dig into the root cause so the same problem doesn't come back. I'm EPA certified and have worked with both R22 and R410A refrigerants. One thing I take pride in is how I communicate with customers. I always explain what I'm doing in plain terms and offer options when possible. I've found that a clear explanation and good attitude go a long way. I also value safety and double-check everything before leaving a job site. I'm always looking to keep learning and stay current with new tech, especially smart home systems and more efficient HVAC models. Here's a perfect answer for someone with limited HVAC experience. I'm just starting out in the field, but I completed my HVAC training at a technical college and earned my EPA Section 608 certification. The program gave me a strong foundation in system installation, basic electrical, airflow, and refrigeration cycles. I've done hands-on lab work where we practice brazing, charging systems, pressure testing, and diagnosing simple issues like faulty capacitors or clogged filters. During my externship, I shadowed techs on residential service calls and learned a lot about what it's like out in the field. Things like dealing with customers, handling emergency calls, and working in tight spaces or tough weather. I always came prepared, asked questions, and helped however I could. I know I still have a lot to learn, but I'm a fast learner, and I'm serious about building a long-term career in HVAC. I'm looking for a company where I can continue developing my skills and work hard as part of a team. I bring a strong work ethic and a real interest in the trade. Question number 2. How do you stay current with new HVAC technologies and systems? HVAC systems and technologies are constantly evolving with new energy standards, smart systems, and efficiency regulations. Hiring managers ask this to see if you're proactive about learning and staying updated. They want technicians who can handle modern systems confidently and aren't stuck in outdated methods. This shows whether you take pride in your work and invest in your own growth. I stay current by combining hands-on experience with continued learning. I subscribe to HVAC trade magazines and follow manufacturers like Trane, Carrier, and Lennox to keep up with product updates. I've also completed recent training in variable refrigerant flow VRF systems and smart thermostats like Ecobee and Nest. When new codes or efficiency standards come out, I make it a point to read through them and ask questions when working with more experienced techs. I also take online courses when I have downtime, especially through NATE or HVAC school. In this trade, things change fast, from refrigerant types to smart home integration, so staying sharp helps me work safely and give customers better service. It also gives me confidence on the job because I know I'm using the most current tools and methods. Question number 3. What types of HVAC systems are you most familiar with? Hiring managers want to know whether your experience matches the systems you'll be working on if hired. They're looking for candidates who can hit the ground running. This also tells them how broad your experience is and where you might need more training. I've worked on a wide range of residential and light commercial HVAC systems, but I'm most familiar with split systems, packaged units, heat pumps, and gas furnaces. I've done everything from troubleshooting blower motors and flame sensors to installing high-efficiency air conditioners and zoning systems. In commercial spaces, I've serviced rooftop units, mini splits, and smaller chiller setups. I've also had experience working with both R410A and R32 refrigerants, and I understand the importance of EPA compliance. I've installed smart thermostats, helped improve airflow through duct modifications, and diagnosed refrigerant leaks using both electronic and bubble leak detectors. While I'm strongest with residential systems, I'm comfortable working in commercial environments too. I like the variety and the challenge of adapting to whatever setup the customer has. I'm also happy to keep learning new systems as needed. It keeps the job interesting. Question number 4. Describe a time you dealt with a difficult customer. How did you handle it? This question helps hiring managers see how you handle pressure and represent the company. HVAC work often involves being in someone's home or business, so how you treat people matters. They want someone who can stay respectful, solve problems, and keep customers calm, even when things don't go perfectly. I had a customer who was upset because their AC had stopped working in the middle of a heat wave and they thought the issue should have been fixed during our previous visit. When I arrived, they were pretty frustrated and raising their voice. I let them vent, stayed calm, and said, "I understand how frustrating this must be. I'll take a fresh look and explain exactly what I find." Turns out the issue was a separate part failure, unrelated to the repair we'd done earlier. I walked them through what went wrong, showed them the part, and explained how I'd fix it and how long it would take. I also gave them a quick tip on checking the air filter regularly, which helped build trust. By the end, the customer thanked me for taking the time to explain things clearly. I've learned that listening without interrupting, staying respectful, and being transparent can turn a tough call into a good experience. Question number 5. What steps do you follow during a routine HVAC maintenance visit? Hiring managers want to see that you follow a consistent, thorough process when performing maintenance. Skipping steps can lead to safety risks or missed problems. This question also tells them how organized and reliable you are in your work. During a routine maintenance visit, I follow a detailed checklist to make sure everything's covered. First, I shut off power and check all electrical connections, tightening any loose terminals and looking for signs of wear. Then I clean the condenser and evaporator coils, check refrigerant levels, and test the capacitor and contactor. Next, I inspect the air filter, blower wheel, and thermostat operation. If it's a furnace, I check the heat exchanger, flame sensor, and burners. I also make sure the drain line is clear and that airflow readings are within the right range. Before wrapping up, I test the system's full operation to make sure it's running efficiently and safely. I document all findings, note any potential issues, and explain them clearly to the homeowner. The goal is not just to prevent breakdowns, but to give the customer peace of mind. That kind of service builds trust and keeps them coming back. Question number 6. How do you ensure safety while working on HVAC equipment? Safety is critical in HVAC work because technicians deal with electricity, refrigerants, gas lines, and high-pressure systems. Hiring managers ask this to see if you follow proper procedures and understand the risks involved. They want to make sure you'll protect yourself, your team, and customers. It also shows how disciplined and detail-oriented you are, which reflects your overall reliability. Safety is the first thing on my mind before I even step into a job. I always start by shutting off power to the unit and confirming it's off with a meter, no guessing. I wear the right PPE for the job, like gloves, safety glasses, and sometimes a respirator, depending on what I'm working with. If I'm handling refrigerants, I follow EPA guidelines and make sure my recovery system is set up properly. I also do a walkthrough of the job site to check for hazards like loose wires or poor ventilation. Lockout tagout is standard if I'm working in a commercial setting. Even with routine jobs, I double-check connections and secure any loose parts before powering equipment back on. Safety isn't just about checking boxes, it's about building habits that protect everyone involved. I've seen what can go wrong when steps get skipped, and it's not worth the risk. Question number 7. What tools do you always carry in your HVAC tool bag and why? Hiring managers want to know how prepared and efficient you are on the job. This question reveals whether you understand the demands of the work and have the hands-on experience to show up ready. It also highlights your ability to prioritize tools that help with diagnostics, installation, and safety. I always keep my core set of tools with me, no matter the job. That includes a multimeter because diagnosing electrical issues is a big part of HVAC work. I also carry a set of gauges, a refrigerant scale, and my vacuum pump for charging and evacuating systems. Wrenches, nut drivers, a thermometer, and an inspection mirror are always in the bag too. For residential work, I keep a combustion analyzer and manometer handy when checking furnaces or gas pressure. I like having a small flashlight and headlamp for tight spots and zip ties or wire nuts for quick, clean fixes. These tools help me work efficiently without having to make repeat trips to the truck. Over time, I've learned what's essential and what just slows you down. Being organized and well-equipped saves time, keeps the customer happy, and makes the job go smoother. Question number 8. Have you ever had to diagnose a system without a clear error code? How did you troubleshoot it? Not all HVAC problems come with a neat error message. Hiring managers ask this to understand your problem-solving skills, especially in situations where logic, experience, and patience are key. They want to see that you can think critically, follow a process, and not rely entirely on technology to do the diagnosing for you. Yes, I've definitely run into that, especially on older systems that don't have digital displays. One time I got called out to a house where the AC wasn't cooling, but there were no error codes and the thermostat seemed fine. First thing I did was check for airflow, filters, vents, return grill. Then I moved to the outdoor unit. The compressor was running, but the refrigerant lines weren't getting cold. I put my gauges on it and saw low pressure, which pointed to a leak. I used soap solution to check fittings and found a tiny bubble at a brazed joint. I recovered the refrigerant, repaired the leak, pulled a vacuum, and recharged the system. It was running like new after that. When there's no code, I go back to basics. Check power, airflow, refrigerant levels, and control signals. A systematic approach almost always leads to the answer. I've learned that taking the time to observe and test carefully saves time in the long run. Question number 9. How do you prioritize service calls during a busy shift? Hiring managers ask this to understand how you manage time, urgency, and customer needs under pressure. In HVAC, it's common to get several calls at once, especially during peak seasons. They want to know you can think clearly, balance safety and efficiency, and communicate well with both dispatch and clients. This shows your ability to stay organized while keeping customer satisfaction and system performance in mind. When I'm faced with a packed schedule, I always start by reviewing the urgency and type of each service call. If someone's AC is out in 100-degree weather or there's a no heat situation in winter, those go to the top of the list, especially if there are young kids or elderly people in the home. I also look at potential safety issues like gas leaks or electrical faults. Those take priority over routine maintenance. I stay in close contact with dispatch so we can adjust as needed throughout the day. If I know a job will take longer or I hit unexpected issues, I give them a heads up so they can shift things around or notify the next customer. I always try to strike a balance between fast response and doing quality work the first time. Clear communication, quick decision-making, and flexibility are key to keeping the day moving and the customers satisfied. Question number 10. Are you comfortable working in extreme temperatures or tight spaces? Can you give an example? HVAC technicians often deal with hot attics, cold rooftops, and cramped crawl spaces. Employers want to make sure you're aware of these conditions and able to work through them safely and professionally. It's also a way to see if you're physically prepared for the demands of the job and can keep calm under discomfort. The right candidate understands what the work involves and doesn't shy away from it. Yes, I'm definitely comfortable working in extreme conditions and tight spots. It's part of the job. I've done summer attic work in over 120 degrees Fahrenheit heat and been in basements with barely enough space to turn around. One time, I had to repair ductwork in a crawl space that had standing water and very little clearance. I wore the right gear, stayed focused, and got it done safely. What helps is going in prepared. I keep a change of clothes, extra water, and cooling towels in my truck during the summer. I also pace myself and take short breaks when needed to stay sharp and avoid heat exhaustion. In my view, it's just part of doing what needs to be done to keep the customer comfortable. As long as I have the right tools, safety gear, and a good attitude, I can handle just about any environment I'm sent into. Let's now explore some advanced HVAC interview questions based on your background and experience. Question number 11. Can you walk me through your process for diagnosing and repairing a short-cycling air conditioning unit? Hiring managers ask this to assess your technical know-how and how methodically you approach problem solving. Short cycling can result from a range of issues: thermostat problems, refrigerant levels, dirty filters, or even oversized systems, so they want to see if you can troubleshoot thoroughly without jumping to conclusions. They also want to know you can communicate your process clearly and safely, which is important when you're working solo or talking with the customer. I start by confirming the customer's complaint and asking a few quick questions: how long it's been happening, any recent service, or if they've changed any settings. Then I check the thermostat to make sure it's working correctly and placed in a good location, not near vents or windows that could affect the reading. Next, I inspect the air filter and evaporator coil. If either's clogged, that could restrict airflow and cause short cycling. I also look at refrigerant levels. Low refrigerant can trigger the system to shut down early. Then I move to the outdoor unit and test the capacitor, contactor, and pressure switches. If it's an oversized system, which I've run into in residential installs, I'll explain the issue and recommend possible solutions like a variable speed blower or zoning. Throughout the process, I keep the customer in the loop and walk them through my findings in plain language. It's important they feel confident in the fix, not just the repair. Question number 12. What's your experience with variable refrigerant flow, VRF, systems or building automation systems, BAS? Hiring managers ask this to understand how comfortable and capable you are with modern HVAC technology. VRF systems and BAS are becoming more common in both commercial and residential applications across the US, so they want to see whether you've worked with these systems or are at least open to learning them. They're also trying to gauge your technical background, problem-solving ability, and willingness to stay up to date with evolving industry tools. If you have previous experience working with VRF and BAS systems, you can use the following answer in your interview. I've worked with both VRF systems and building automation systems in my last role, mostly in commercial buildings like schools and mid-sized office complexes. With VRF, I handled installation, diagnostics, and servicing on multi-zone setups. I've had to troubleshoot communication errors between indoor and outdoor units, and I'm comfortable navigating system wiring and using manufacturer-specific tools to recalibrate or update firmware. On the BAS side, I've worked with systems like Train Tracer and Johnson Controls to adjust set points, troubleshoot alarm conditions, and verify sensor accuracy. I'm comfortable interpreting system graphics and coordinating with facility managers to optimize performance. I like working with these technologies because they combine mechanical and digital skill sets, and I enjoy figuring out how everything ties together for energy efficiency and comfort. I also keep up with new tech through manufacturer trainings and online resources. I feel confident walking into a site, pulling up a system dashboard, and knowing what to look for to get things running right. If you have no experience or limited experience working with VRF and BAS systems, you can use the following answer. I haven't had direct hands-on experience with VRF systems or full building automation systems yet, but I've been learning about them and am definitely open to training. In my previous jobs, I've worked mostly with traditional split systems, RTUs, and light commercial HVAC units. I've handled a lot of troubleshooting, refrigerant work, and wiring, so I feel I've built a solid base to transition into more advanced systems. Recently, I started taking online courses and watching tutorials from major manufacturers to understand how VRF systems are designed and how BAS controls operate. I've also spoken with a few techs in the field to get their perspective on the learning curve and best practices. What I bring is strong mechanical aptitude, a good understanding of controls and diagnostics, and a mindset that's ready to grow. I know that technology in HVAC is evolving fast, and I want to be ahead of that curve. If the opportunity comes up to train on VRF or BAS, I'm eager to dive in and get hands-on as soon as possible. Before we continue, I just want to take a moment to thank you for watching this video. You can download a copy of these interview questions and answers in PDF format by clicking on the link below and supporting my channel by making a minimum donation of $3. Your support allows me to keep creating valuable content to help you pass your interview and land your dream job. Thanks for your support and appreciation. Question number 13. How do you perform superheat and subcooling calculations, and why are they important? Hiring managers ask this question to assess your technical understanding of system performance and your ability to troubleshoot refrigeration cycles accurately. Superheat and subcooling are core concepts in HVAC work, especially for ensuring that systems are charged correctly and running efficiently. They want to see if you know how to take the right readings, interpret them, and explain what those readings tell you about a system. A solid answer shows you're both skilled and detail-oriented, which is critical in preventing breakdowns and costly callbacks. To calculate superheat, I measure the suction line temperature close to the evaporator and subtract the evaporator's saturation temperature, which I get from the pressure reading and a PT chart or my digital gauges. For subcooling, I take the liquid line temperature near the condenser and subtract it from the saturation temperature based on the high side pressure. I always make sure I'm using accurate tools, and I double-check my readings before making any charge adjustments. These calculations are important because they tell me how well the system is absorbing and rejecting heat. Too little superheat could mean flooding the compressor, while too much could mean the evaporator isn't being used efficiently. Same goes for subcooling. If it's off, you could be undercharged or overcharged. In both cases, it's not just about numbers. It's about understanding what the system is doing and making sure it's safe and efficient. Getting these right helps extend equipment life, improve performance, and avoid future issues, which customers really appreciate. Question number 14. Describe how you'd troubleshoot a three-phase compressor that's not starting. Hiring managers ask this question to see if you understand how to systematically troubleshoot electrical and mechanical issues in a commercial HVAC system. Three-phase compressors are common in commercial setups, and being able to diagnose one that won't start requires both technical knowledge and safety awareness. They want to hear how you think on your feet, whether you can follow a logical process, and if you understand the risks involved. This also shows your ability to work independently without causing delays or damage to the system. If I'm called out to a three-phase compressor that's not starting, the first thing I do is shut off power and make sure everything's safe to work on. Then I'll check the line voltage at the contactor to confirm if power is reaching the unit. If voltage is present, I'll take a close look at the contactor. Sometimes the contacts are worn out or burnt, and that's a simple fix. If that checks out, I move to the overloads and test each leg to see if the compressor windings have failed or if there's an open circuit. I'll also do a megohmmeter test to make sure the windings haven't shorted to ground. If the windings look good, I'll check phase balance to ensure there's no phase loss or imbalance from the power supply. Throughout, I try to be methodical, one test at a time, starting from the power source and working toward the compressor. That way, I'm not guessing or swapping parts unnecessarily, and I can explain the problem clearly to the customer. Question number 15. What's your understanding of static pressure and how it affects system performance? Hiring managers ask this to check your understanding of airflow and how it impacts HVAC system efficiency. Static pressure is one of those fundamental concepts that separates an average tech from a great one. They want to know if you recognize the symptoms of high or low static pressure and how to correct them. This shows whether you approach service calls with a diagnostic mindset, not just part swapping. Static pressure is basically the resistance air meets as it moves through a system. Too much static pressure, whether from dirty filters, undersized ductwork, or closed dampers, can put stress on the blower motor and reduce airflow to the space. That leads to longer run times, higher energy use, and customer complaints about comfort issues. I always measure static pressure when I'm troubleshooting low airflow or unusual noises. One job that stands out was a home where the customer had rooms that weren't heating evenly. I found the static pressure was way too high due to a combination of restrictive filters and a poorly designed return duct. After replacing the filter with a less restrictive one and recommending duct adjustments, static pressure dropped, airflow improved, and the system ran quieter. Understanding static pressure helps me catch issues others might miss. It's one of those things I always check now, even during maintenance calls. Question number 16. Can you interpret a complex HVAC wiring diagram and explain a recent time you used one in the field? This question tests your ability to read wiring diagrams, something that's crucial when diagnosing electrical faults. Hiring managers are looking for techs who don't just guess at issues, but know how to follow a diagram and isolate the problem. They want to know you're safe, thorough, and able to work independently in complex situations. Yes, I'm very comfortable reading HVAC wiring diagrams. Whether it's a packaged unit or a split system, I use the wiring diagram as my guide whenever I'm dealing with electrical issues. One recent example was a rooftop unit that kept tripping the breaker. The system had multiple safeties and a fairly complex control board. I pulled the wiring diagram and traced the power through each safety device. I found the low-pressure switch was opening intermittently due to a loose terminal connection. Without the diagram, it would have taken a lot longer to narrow that down. I tightened the connection, tested everything again, and the unit ran fine. Using diagrams saves time and reduces mistakes. I've learned that guessing leads to callbacks, but following the wiring step by step leads to solid fixes. It's one of the tools I rely on most when diagnosing. Question number 17. What's the most difficult refrigerant leak you've ever found and repaired? What made it challenging? This question helps them understand your troubleshooting skills and how persistent you are when a leak isn't easy to find. Hiring managers are looking for someone who doesn't give up and uses the right tools and methods instead of just topping off refrigerant. It's a good way for them to gauge your experience and how you handle tough service calls. The toughest refrigerant leak I ever dealt with was on a residential mini-split system. The homeowner said the unit had been topped off twice by another company, but still wasn't cooling after a couple of weeks. I started with an electronic leak detector but didn't pick up much. I then did a nitrogen pressure test and soap test, but still couldn't find the leak. I suspected the leak was inside the evaporator coil, so I pulled it and did a water submersion test in the shop. That's when I finally saw a slow stream of bubbles near a micro crack in one of the bends. It was so small it didn't show up on any other test. I replaced the coil, recharged the system, and it's been working perfectly since. What made it challenging was how small and well hidden the leak was. It reminded me how important it is to be thorough, patient, and not rely on just one method. Customers appreciate when you go the extra mile to get it right the first time. Question number 18. How do you ensure compliance with EPA regulations? When handling refrigerants, hiring managers ask this to make sure you're qualified and take environmental regulations seriously. Proper refrigerant handling isn't just about doing the job right. It's a legal responsibility. They want to see that you understand the rules, use the correct procedures, and are careful to prevent leaks or improper disposal. It also shows your attention to safety, documentation, and professionalism on the job. I'm EPA Section 608 certified, so I understand the importance of following federal regulations when it comes to refrigerant handling. I always use recovery machines and follow proper evacuation procedures before opening any system. I label all recovered refrigerant clearly and store it in approved cylinders, and I keep a log of each job for tracking and compliance. When disposing of appliances, I make sure refrigerants are properly removed before recycling or replacement. I also double-check that all connections are sealed tightly after recharging to avoid leaks. If I suspect a system is leaking, I'll use a leak detector or nitrogen pressure test to confirm before proceeding. I take these steps seriously because the environmental impact is real, and non-compliance can result in hefty fines or even loss of certification. My goal is to do every job safely and by the book, and I always stay up to date with any changes to EPA guidelines. Question number 19. What advanced controls or smart thermostats have you installed or programmed? This question helps hiring managers understand if you're up to date with modern HVAC technology. Smart thermostats and advanced controls are common in both residential and commercial systems, and they want to see that you're comfortable installing, setting up, and explaining these systems to customers. It also shows that you understand energy efficiency, system integration, and troubleshooting. I've installed and programmed a range of smart thermostats, including the Nest Learning Thermostat, Ecobee Smart Thermostat, and Honeywell T6 Pro. Most of my experience is in residential settings, but I've also done light commercial installs where programmable zoning systems were used. I always start by confirming compatibility with the system, whether it's single-stage, multi-stage, or has heat pumps. Once installed, I walk customers through setup, show them how to connect it to Wi-Fi, and help them create schedules that balance comfort and efficiency. I also make sure they understand any energy-saving features, like geofencing or occupancy sensors. On commercial jobs, I've worked with BAC net-compatible thermostats that integrate with building management systems. I've helped program time-of-day settings, seasonal temperature changes, and even remote access through apps or dashboards. With how quickly tech evolves, I try to stay current by reading up on new features and watching training demos from manufacturers. The better I understand the tech, the easier it is to make sure the system works right and the customer feels confident using it. Question number 20. Explain the steps for properly evacuating and charging a system with R410A. What mistakes do you watch out for? Hiring managers ask this to assess your hands-on technical knowledge and your understanding of safety protocols and EPA standards. They want to know if you're precise with your work and understand the importance of clean evacuations, accurate charging, and avoiding system contamination. It also shows if you're careful with high-pressure refrigerants like R410A, which behave differently from older refrigerants. Your answer gives them a glimpse into your field readiness and attention to detail. When I'm working with an R410A system, I always start by making sure I recover any refrigerant left in the system using a recovery machine and tank rated for high pressure. Once that's done, I hook up my micron gauge and pull a deep vacuum, usually down to 500 microns or lower, to make sure there's no moisture or air left inside. I leave it sitting in vacuum for a while to verify it holds, which confirms there are no leaks. When charging, I always use a scale because R410A is a blend and needs to be charged by weight as a liquid. I make sure the system is running before charging and charge through the liquid line slowly to avoid slugging the compressor. I double-check manufacturer specs for the exact charge. One mistake I always avoid is charging with vapor or skipping the vacuum. Either can cause performance issues or damage. Getting the process right helps avoid callbacks and makes sure the customer's system runs smooth and efficient. Question number 21. What does BTU, CAV, and AHU mean? Hiring managers ask this to make sure you understand key technical terms you'll use on the job every day. These acronyms are foundational in HVAC systems, and knowing what they stand for and how they apply is a sign that you're not just trained, but ready to troubleshoot and communicate with customers or team members. They're also checking if you can explain complex terms in a clear and confident way, which matters when talking with clients or new apprentices. BTU stands for British Thermal Unit. It measures the amount of energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. In HVAC, we use BTUs to figure out how much heating or cooling a space needs. The higher the BTUs, the more powerful the system. CAV means constant air volume. It's a type of HVAC system that delivers the same amount of air all the time, but the temperature of that air changes to meet the heating or cooling demand. These systems are common in small to mid-sized buildings where the air needs are steady. AHU stands for Air Handling Unit. That's the piece of equipment that moves air throughout the building. It usually includes components like fans, coils, filters, and dampers. The AHU is often connected to ductwork and works with the chiller or furnace to control temperature and air quality. These terms come up all the time in the field, so it's important to not just know them, but be able to explain them clearly on the job. Question number 22. What is a cooling or heating load? How do you calculate it? Hiring managers ask this to assess your technical knowledge and whether you understand the factors involved in sizing HVAC systems correctly. An accurate load calculation affects comfort, energy efficiency, and long-term system performance. They want to see that you don't rely on guessing or rule of thumb methods. This question also shows if you understand the importance of matching equipment to the space it serves. A heating or cooling load refers to how much heating or cooling a space needs to maintain a comfortable indoor temperature, considering the outdoor conditions. To calculate it, I look at several factors like square footage, insulation levels, window sizes and types, local climate, number of occupants, and internal heat gains from lights or appliances. I use Manual J for residential load calculations, which gives a much more accurate picture than estimating. For commercial systems, I've worked with software like WriteSoft or CoolCalc to handle more complex scenarios. The goal is to avoid undersizing or oversizing, because both can lead to system inefficiency and higher energy bills. Whenever I do a load calculation, I double-check measurements and cross-reference with the building layout so the system I recommend matches the actual needs of the space. Doing it right the first time saves a lot of time and headaches down the road. Question number 23. What is the difference between a heat pump, heating, and refrigeration? This question helps hiring managers gauge your understanding of core HVAC systems and how they operate. They want to know if you can explain differences clearly and if you understand the theory behind how heat is moved, not just the tools you use. It's also a test of how well you can communicate technical info, especially when explaining options to customers or team members. A heat pump, heating system, and refrigeration system all work on the same basic principle of moving heat, but they do it in different ways and for different reasons. A heat pump can heat and cool by reversing the refrigeration cycle. It pulls heat from outside, even in cold temps, and brings it indoors and vice versa for cooling. A traditional heating system, like a furnace, generates heat using gas or electricity and pushes it through the ductwork. Refrigeration, on the other hand, is about removing heat from a space, like in a walk-in cooler or a residential fridge, and rejecting it outside to keep the inside cold. The main difference is where the heat is going and whether you're creating it or transferring it. I've worked with all three types of systems, and understanding how they work together is key, especially in mixed-use buildings or modern systems where efficiency is the priority. Question number 24. What are the different ways heat can be lost or gained? Hiring managers ask this to make sure you understand how buildings interact with their environment and how that affects HVAC design and system performance. Knowing where heat is gained or lost helps technicians troubleshoot issues and design better solutions. It shows that you understand the bigger picture beyond just the equipment. They also want to see how well you can assess a space before recommending changes or repairs. Heat can be lost or gained in a building through conduction, convection, radiation, and air infiltration. Conduction happens when heat moves through materials like walls, windows, or the roof, especially if insulation is lacking. Convection involves the movement of air, like when warm indoor air escapes through gaps or cool air enters through pore seals. Radiation is heat transferred from the sun through windows or roofs, which is especially noticeable in rooms with large glass areas. Air infiltration, or leaks around windows, doors, and vents, also adds to unwanted heat gain or loss. When I assess a home or commercial building, I look at insulation levels, window quality, door seals, and duct leaks. Identifying where the building is losing or gaining heat is key to improving efficiency and recommending the right HVAC solution. It's not just about fixing what's broken, it's about understanding the full environment and how it impacts performance. Question number 25. Describe an HVAC job where you sacrificed safety for speed and what was the outcome. Hiring managers ask this to see how you evaluate risk and whether you've learned from past mistakes. Safety is a huge part of the HVAC field, and shortcuts can lead to injury, damage, or liability. They're not just looking for perfection, they want honesty, accountability, and a safety-first mindset going forward. Early in my career, I was working on a rooftop unit during a tight job schedule. I skipped wearing my harness just to get the job done faster, figuring I'd be up there for only a few minutes. Nothing bad happened, but when my supervisor saw it, he pulled me aside and explained how one small mistake could have changed everything. That really stuck with me. Since then, I've made safety my top priority, no matter how rushed the job might feel. I realized that customers would rather wait an extra half hour than have someone get hurt on their property. I double-check gear, follow lockout and tagout, and never work outside the safety guidelines anymore. That experience taught me that getting the job done right includes getting it done safely. Now I always speak up if something feels risky, even if that means slowing things down a bit. Question number 26. How do you handle a customer who is angry or frustrated over their bill? HVAC techs often deal directly with homeowners or business clients, and billing issues are one of the most common causes of tension. Hiring managers want to see that you can stay calm, listen well, and explain things clearly. They're looking for someone who can represent the company with professionalism and patience, especially in tough situations. When a customer's upset about a bill, the first thing I do is listen without interrupting. People want to feel heard, and sometimes just letting them talk helps lower the tension. Once I understand what's bothering them, I calmly walk through the invoice and explain the work that was done, why it was needed, and where the charges come from. If something seems off, I never argue. I offer to double check with the office or the supervisor to make sure everything lines up. I also point out where we saved them money or prevented a bigger issue. In one case, a customer was upset about a diagnostics fee, but after I explained how it saved them from replacing a whole system, they actually thanked me. The key is staying respectful, owning your part, and giving clear, honest answers. I always treat every customer like I'd want someone to treat my own family. Question number 27. In HVAC jobs, did you ever turn an unhappy customer into a happy customer? This question helps hiring managers understand your customer service mindset and your ability to de-escalate problems. In HVAC work, something can go wrong even when you do everything right. What matters is how you respond. They're looking for someone who's professional, solutions-focused, and represents the company well. Yes, there was a time when I went out to a home where the customer said the system we installed wasn't cooling properly. They were upset, thinking we'd rushed the job. I didn't get defensive, I just said I'd be happy to take a fresh look. I ran a full diagnostic and found a thermostat setting had been changed, likely by mistake. I fixed the issue, explained how it affected the cooling, and even walked them through their system so they could feel confident using it. Before I left, I gave them my direct contact in case anything else came up. By the end of the visit, the customer apologized for being short at the start and gave us a great online review. I think the way you handle tough moments can earn more trust than when everything goes perfectly. I always try to be understanding, take ownership, and leave people feeling like we genuinely care. Question number 28. How do you view mobile technology and its role in the future of the HVAC industry? Hiring managers want to see if you're open to new tools and evolving technology. Mobile apps, smart systems, and diagnostics are becoming a bigger part of the HVAC field. They're looking for techs who are adaptable, efficient, and ready to learn as the industry grows. I think mobile technology is becoming a big part of how HVAC techs do their jobs. I use apps on my phone and tablet to pull up service history, access wiring diagrams, and even get real-time help from the office. It saves time and cuts down on mistakes. I also use mobile payment apps and scheduling tools to keep things running smoothly with customers. Smart home systems are another big piece. More customers are asking about Wi-Fi thermostats and remote monitoring. I've trained on a few of those systems and enjoy showing homeowners how to use them. I think as the industry continues moving toward automation and energy efficiency, mobile tools will keep us more connected and allow us to offer better service. I'm comfortable with technology and always open to learning new systems if it helps me work smarter and serve the customer better. Question number 29. What safety violations do you see most often, and how would you prevent them? Hiring managers ask this to make sure you take safety seriously and understand common risks in the field. HVAC work can involve electricity, heavy equipment, confined spaces, and chemicals, so one mistake can cause serious injury. They want to hear how proactive and knowledgeable you are about spotting and preventing issues. It also shows your awareness of OSHA guidelines and company protocols. One safety violation I see pretty often is techs working without lockout.tagout when servicing equipment. It might seem quicker to just flip a switch and get started, but that can go wrong fast if power unexpectedly kicks back on. I've also seen people skip proper PPE, especially when handling refrigerants or working in attics during the summer. To prevent this, I always follow a pre-task checklist and do a quick safety talk if I'm working with others. I make sure we've got the right PPE, confirm power is locked out, and double-check ventilation if we're in a tight space. I also stay up to date on safety refreshers and OSHA requirements. It's not just about protecting myself, it's about making sure everyone gets home safe at the end of the day. I try to lead by example and call things out in a respectful way if I see something off. Question number 30. Are you more experienced with air-cooled chillers, water-cooled chillers, magnetic barring chillers? This question helps hiring managers understand what systems you're comfortable with and where your strengths lie. Different jobs and clients require different expertise, so knowing whether you've worked more with air-cooled, water-cooled, or magnetic bearing chillers helps match you to the right work. It also shows if you've handled larger systems often found in commercial or industrial spaces. I'm most experienced with air-cooled chillers, though I've worked with water-cooled systems as well. A lot of the commercial properties I've serviced use air-cooled chillers because of the lower maintenance and easier installation. I've done full system diagnostics, coil cleanings, refrigerant recovery, and compressor replacements on those units. I've also worked on water-cooled chillers, especially in buildings with higher cooling loads like hospitals or data centers. I understand the pump and tower setups, and I'm comfortable with tasks like descaling tubes and monitoring water treatment. I've only had limited exposure to magnetic bearing chillers, but I'm definitely interested in learning more. If a job requires training on those newer systems, I'm more than willing to take it on. I like expanding my skill set and staying current with technology. It helps me stay valuable to the team and the client. And finally, here's the last question, question number 31. Do you do residential chillers? This question helps the employer figure out what environments you're comfortable working in. Residential and commercial systems can be very different, not just in size, but in how you interact with customers and structure the work. They want to know if you're adaptable and understand the needs of homeowners when it comes to chilled water systems or mini splits. I've worked on residential chillers, but they're less common than what I usually see in commercial settings. Most of the residential systems I've dealt with are high-end homes that use small-scale chilled water systems or ductless mini splits. I've handled installations, diagnostics, and refrigerant charge adjustments for those setups. When I'm in a residential setting, I know how important it is to communicate clearly with the homeowner, be clean and respectful in their space, and explain what I'm doing in simple terms. They're trusting you with their home comfort, and that trust matters. Even though I have more commercial experience, I'm comfortable shifting gears for residential work. I stay up to date on codes and best practices for both. I think being versatile is a big part of staying reliable in this field. If you want to learn more on how to land jobs and reach your career goals, don't forget to hit that subscribe and bell notification button to get new videos every single week. Also, don't forget to hit that like button because that motivates me to keep doing what I do. Stay safe, keep smiling, and good luck.